Hey guys, welcome back to my channel. In this video we are going to learn about the diagnosis, like the difference between hepatic jaundice, hemolytic jaundice or prehepatic, and post-hepatic jaundice. I don't know why this guitar is here, but I like this guitar, so it's going to be here. There should be no problem with that. Okay, so moving on. First we talk about obstructive jaundice. You see, I created that suspense with this guitar. Okay, so in obstructive jaundice, first we have the chart which we mostly follow for obstructive jaundice. Like the main clinical features which we look out for is the ALT, AST, and ALP levels. AST and which are the liver enzymes, the bilirubin level, conjugated, unconjugated, and the urobilinogen level in the urine. So these are the main laboratory findings from which we know whether the person has obstructive jaundice or not, or not only obstructive, like any type of jaundice. So in obstructive jaundice, the liver enzymes are mainly ALT, AST, and ALP. ALT and AST is more or less in the normal range, which is alkaline aminotransferase and aspartate aminotransferase. They are more or less in the normal range, but the main liver enzyme which we have to look out for in obstructive jaundice is alkaline phosphatase. Alkaline phosphatase will be elevated in cases of obstructive jaundice. Then we'll check the bilirubin levels. So first I'll tell you what exactly is bilirubin. So we all know red blood cells which are present in the blood. Red blood cells are present in the blood. The average lifespan of a red blood cell is 120 days. This I think almost, or even now the kids who are learning science, who are learning biology, even they'll know average, like the life cycle on mostly in almost all individuals is around 120 days. So after 120 days, when the RBC is lysed, the hemolysis can either be intravascular, that is in the blood vessels, or it can be in the spleen, which is also known as RBC's graveyard. So after hemolysis, the hemoglobin molecule which is present in the RBCs is lysed into the separate components heme and globin. Now the globin is the protein component. It goes along with the other protein, it dissociates into amino acids, and then it goes on to form other proteins present in the body. The heme part, heme is degraded into biliverdin. Now this biliverdin is converted to bilirubin. Now the bilirubin which is formed from heme is in unconjugated form, and that in that sense it is not soluble in water, and bilirubin is not required by the body like the normal, it should not be present in the body in that much an amount, so it has to be excreted. Now for any substance in general to be excreted through the kidneys, that is through urine, it needs to be water soluble. Bilirubin is present in unconjugated form, so it's not water soluble. To make it water soluble, it goes in the liver where there's an enzyme, like there's a little dude there present in the livers, like called UDP, glucouronal transferase. Now this enzyme dude, like, he's very cool. He's like, you are not water soluble, okay, I'll make you water soluble. So he makes the unconjugated bilirubin water soluble, converting it to conjugated bilirubin. Now this conjugated bilirubin can be excreted in urine because it's water soluble. So this conjugated bilirubin, it is excreted through bile into the intestine. In the intestine, it is converted to urobilinogen, which is converted to stercobilinogen, and this stercobilinogen, guys, is responsible for the brown color of feces or stool which you see in the washroom every day. Yeah, this stercobilinogen So in cases of obstructive jaundice, because there is an obstruction, the conjugated bilirubin is not able to come into the intestine. Because it doesn't come in the intestine, it cannot be converted to stercobilinogen. So because stercobilinogen is not formed, the feces which you see every time you go to for a long toilet in the washroom will not be brown, like the characteristic brown color. It will be clay colored or pale in appearance because stercobilinogen is not there. Now this was about obstructive jaundice, like and because there is obstruction, the conjugated bilirubin is not excreted through intestine, so the conjugated bilirubin levels will rise up. So there is increased conjugated bilirubin, and as I told earlier, there is increased alkaline phosphatase, which is the liver enzyme. There will be no urobilinogen in urine because urobilinogen is absorbed from the enterohepatic circulation once it comes in the intestine, so it will not be present in urine, but the urine will be dark in color because of excretion of bilirubin, like sorry, just ignore that part. There's no urobilinogen in urine. So this is about obstructive jaundice. Now moving, which is also known as post-hepatic jaundice, because problem is not in the liver, problem is after the function of the liver, after function of the DUD enzyme, that is UDP, glucuronidase transferase. It is after that, because there's obstruction in the flow of conjugated bilirubin formed in the liver. So it's also known as post-hepatic jaundice. Now we come under hepatic jaundice. In hepatic jaundice, there's problem in the liver. So there was this dude present in the liver who was converting the unconjugated to conjugated bilirubin. Now this dude is not able to function properly. I don't know, maybe he has got a breakup with his girlfriend or something, or maybe he's just too pissed that he has to do so much work. He's not functioning properly. So because he's not functioning properly, there is elevation in both conjugated and unconjugated bilirubin, like both. Like some of them is getting converted, but not all of them. So there's elevation in both. Now the liver is not functioning properly, so all the liver enzymes will be elevated, including aspartate aminotransferase, alkaline aminotransferase, and alanine aminotransferase and alkaline phosphatase. All AST, ALT, ALP, all are elevated, and these are the main findings in case of hepatic jaundice. Here the problem lies in the liver cells, in the enzyme which is present in the liver, like mainly in the liver cells. They are not able to, the enzyme is functioning, but it has to do all the work alone, so all the stress is on it, so it's frustrated, and the other enzymes are not able to get secreted. Okay, so this was about hepatic jaundice. Now we talk about prehepatic jaundice. Over here the problem lies before the conjugated bilirubin comes into the liver. Here, now we all know that the normal process of how bilirubin is excreted. In case of prehepatic or hemolytic jaundice, which is mostly seen in hemolytic anemias, here there is excess lysis of RBCs. Even the healthy RBCs are lysed at an early stage. It occurs both like in the blood vessels, in spleen, like everywhere there is excess lysis of RBCs. So there is increased production of unconjugated bilirubin in like the which is not water soluble, like increased unconjugated bilirubin. Now this liver is normal, so all the unconjugated bilirubin normally are going into liver and they are getting converted to conjugated, but there are too much of unconjugated bilirubin, so the liver is not getting enough time to convert all of them to conjugated. Therefore the unconjugated bilirubin is increased. Now here the liver is functioning properly, so all the liver enzymes are within the normal range. Now, in case of prehepatic or hemolytic jaundice, the conjugated bilirubin, which is formed in the liver, it will go into the intestine. From the intestine, most of the products, they are absorbed from the intestinal walls and they enter the enterohepatic circulation. That is, they are absorbed, like after release from the liver, they are absorbed. They'll again go through the cycle in the liver, and because the conjugated bilirubin is going through this cycle in the blood, some amount of the conjugated bilirubin is converted to urobilinogen, which enters the enterohepatic circulation involving the liver. Now, because urobilinogen is already present in the blood, becomes present in the blood, it can be excreted through the kidneys in urine. And as we know, urobilinogen is formed from conjugated bilirubin, which is water soluble, so kidneys can easily excrete it. So there will be elevated urobilinogen levels in the urine. So this was about hemolytic jaundice and prehepatic jaundice. Now, to concise all of it at once, whatever is required for this diagnosis, for obstructive jaundice, main thing we have to see is the alkaline phosphatase enzyme, ALP, which is the liver enzyme, will be elevated. There will be elevation of conjugated bilirubin. Urobilinogen may or may not be present in the urine, and there will be clay colored stool because stercobilinogen is absent. Then in hepatic jaundice, the liver enzymes will be elevated, that is aspartate aminotransferase and alanine aminotransferase. These are elevated there will be elevation in both unconjugated and conjugated bilirubin. Then we have the prehepatic or hemolytic jaundice. In prehepatic or hemolytic jaundice, we will see elevated levels of unconjugated bilirubin, and urobilinogen will be present in the urine because it enters the enterohepatic circulation, from which some amount of urobilinogen is excreted through kidneys. So that was it for this video. Today we learned about prehepatic, hepatic and post-hepatic jaundice, that is hemolytic, hepatic and obstructive jaundice. For more such video, please subscribe to my channel, and please like this video, and please make sure to comment whether you found this useful or not, or whether you learned a new thing. So that's it for this video. Thanks for watching. Okay, I'm not going to irritate you with this. Bye bye.